Today we're going to explore how Wagners CFT is improving FRP infrastructure delivery through practical drafting standards that enhance clarity, reduce errors and support efficient construction outcomes. Good morning and welcome to our webinar, The Right Connection Drafting Guide Part 3. I'm Kelly Stewart. Georgia, I'll just get you to flip slides if you could, please. I'm Marketing Manager here at Wagners CFT. We are having some technical problems this morning with Georgia. We'll fix those shortly. And I'm going to present in the meantime while we get those things sorted. Jason, I'd like to introduce, has been with Wagners for more than 15 years, bringing extensive experience in drafting, design coordination, and the technical software used to deliver construction projects. As Design Manager at Wagners CFT, he oversees the design and documentation process for a wide range of infrastructure projects, managing the production of technical drawings and construction plans from concept through to delivery. Working closely with engineers, project team and clients, Jason ensures designs are accurate, practical and aligned with project requirements. His technical expertise and attention to detail play a key role in the successful delivery of Wagners CFT projects. We're also joined by Wagners CFT General Manager for Australia and New Zealand, Ryan Leeson. Ryan will be representing those of us who don't live in the CAD world every day, helping to translate the technical details and make sure we ask the questions everyone else is thinking. So welcome, Jason and Ryan. Before we get started, just a few webinar protocols. We are recording today's event and we will make the recording public via the Wagners CFT YouTube channel. You can ask a question anytime during the webinar via the chat bubble at the top of the screen. However, we will hold your questions over to the end of the webinar for the Q&A session. And for anyone having difficulties accessing the chat facility, feel free to text your questions directly to Georgia on the mobile phone number that I've just popped in the chat there for you now. So let's dive in today's webinar. I'll hand over to Jason and fingers crossed we don't have any more technical problems.
Thanks, Kelly. All right, guys, I will just drop in straight into the drafting guide, because that's why we all are here today. Let me see if we can pull this up. Back. So is that coming through?
Yep, it's just loading the content.
Yep. All right, I'll take a bit.
Brilliant. We're online.
Okay. So we've developed this kind of drafting guide over the last kind of couple of years. We've put it together, but it categorizes basically our development over the past 15, 20 years. 15 years for myself, but 20 years for the whole business. So this is probably just the front page. We've included all our typical notes. Now, all these have come available both in CAD and Revit formats for yourself as well. We've provided a bit of a kind of a structure layout for our kind of typical structures. As you can see here, we've got our splicing details. So these are for our driven piles. You can see here that there's our square sections, and if I move on to the next page, we've got some of our round section piling splice details. For those that, we don't want to use driven piles for those, jobs, we also have board pier details, pad footings, and even into screw pile connections and other alternative connections in here. I think I've even got one little and then moving on, standard abutment details of how we've developed our abutments to limit any settlement between the path and boardwalk. This is typical kind of abutment here. for most of our structures. When we don't use concrete, we've got a kind of earth retention detail here. Moving on, all our standard connections, so pile and bearer, joisted bearer kind of details, and I move into handrail connections. So all our typical handrail details are kind of catered for in here, even on concrete paths. So the drafting guide caters for a lot of our connections, been developed over many years. In development, we're still developing them, and they do change over time. So this is kind of a little bit of a live document. So so I'll move on to.
So Jace, just go back a step for us. The overarching intent of publishing the design guide was to make the design tools and the what we consider best practice available for other design consultants and contractors to be able to use. That's the objective? So what we're enabling here is simplicity of design by others using our products. Is that what we're coming down to?
Yeah, so we've developed like the connections that kind of work well, both in constructability and estimate, cost wise, all that kind of stuff. Things that we've worked with over the years and go, this works both from a cost point of view and a development point of view and a constructability point of view, to best give us the best outcome for our structures. So we've made those available to anyone that wants to use them, and this helps just give it better structures to our designers. So we're going to move into kind of how we kind of use this document. So I'll switch over to my slides. Yeah, so today I'll go through just a couple kind of standard connections that we use, kind of using the drafting guide to pull from to create our drawings. I've catered this on one project that I've pulled all these from, and then I'll go into some kind of just some common drafting and design kind of errors and that things that we might things that make a project get a little bit stuck in times. So moving on to the first one is our kind of crush block. So there's most of our bolted connections. So here we have the project that I'm doing this kind of bit of case study on. We have a typical bearer to pile connection here. So then going straight to the drafting guide, I've pulled that same connection from the drafting guide there, and then kind of placed it into my drawings. I've got here different variations of basically the same design, because this is a set of stairs, so we do have different kind of variations. Like you have a stepped bearer down the bottom here with detail 2, because you got one side it's a stringer, the other side's a joist. So we do have kind of little variations here, but essentially they're all the same detail. Yeah. Moving on to bush connections. Bush connections we use a lot for where we want flexibility on site. So we commonly use these for like handrail posts, and anywhere where we don't need to use the crush block for its connection capacity. So we might use it for braces as well in the piles as another option, and any, yeah. So here again, we have a typical handrail post connection. So when I go to the drafting guide, I'll go directly to this connection, which is a fair way into the document, but the document's set out in a way that, and you can see I've got here the title page, so you can get a view of where to find all your connections fairly easily. So yeah, this is taken straight from the drafting guide, and then again copied and pasted it into my into my set of drawings for this one project. Excuse me. And then the third kind of connection that we use quite frequently is our riveted connections. We use these for joist bearer connections, and also here, which I'm going to use as an example, is the rail to post connection on this job. So and that, that's our typical detail there with our riveted connection for our post to rail. In this variation that I want to use, so we have many different options here of different rails. So this is bottom rail, and a different variation for like a top rail mounted to the side. In this case, this project I'm using is mounted, in between posts. So that's why I use that top one. And then copied straight into my drawing, I use the same connection with the riveted brackets. And that, with this one also, I kind of used a bit of a variation in this. So I don't currently have stair rail connection details in the drafting guide, but this is an example where I've kind of used the same connection but varied to suit the case. So with riveted angles, we want to keep them in positions where they're greater than 90 degrees. This allows us to use a rivet gun to bolt these on. So if I put it, both cases underneath on this one side, on the low side, that wouldn't be able to be constructed. So that's why we put one on top, one underneath, to keep them open, greater than 90 degrees. 90 degrees or greater is the key with any riveted connections. So yeah, as a summary, we want to be wary. Crush blocks, we use them where we kind of need to use them. They have a few constructability requirements. One is that generally there is only a central hole for the bolt. If we require like two bolts, or we want the bolt to be in a different position that's not in the center, we may have to look at a different connection there. So that's one thing to allow. The other thing is their preparation. They need to be pushed into place. So we don't want to use them for the handrail posts. Using cross blocks in the joists, because then you kind of have to push that one a long way down the member. So that's one thing. The next thing is that our guide, I've tried to cater this for like the bulk of most of our projects. So I'll say this guide includes about 80% of our typical connections. Includes many of our standard kind of tables of info for like bush sizes and all our notes. As I've said before, this is a bit of a live document. I will be updating it from time to time. And I've made it all available in both Revit and AutoCAD, so that you can use it on your designs. So I'll move into some of the things that I've found over the years that kind of can inhibit our design, the designs, and kind of the whole progress of a structure. So moving on to like the first kind of case study here. This is a design that was designed a couple of years ago. From the outset, it looks like all the design's been done. It was certified for construction, but as we take a bit of a closer detail of the connections, you can kind of see what I've highlighted here. The detail of the connections is fairly light on. This allows assumptions to be made by the contractors that are bidding for the design and that. So, and then the other thing is there's a lot of words here. Some crucial kind of details can get lost. So we find, pictures are worth 1,000 words. Actual connection details tells the construction much better than a couple of words and a bit of text, and then allows other things to be more easily known, like glued inserts. These glued inserts require preparation. Because they need to be done here in our factory. They can't be done on site or anything like that. So, we want to limit our glue connections to, parts where we don't need the flexibility of things. So, wherever we can pull these actual connections from the drafting guide. So for example, this one with the L bracket, we can pull that straight joist to bearer connection straight from the drafting guide and use a bit of a call out and refer to that detail much easily than that little connection bit of text. The second example here, moving on, is a lot of times we draft in 2D. So although on the picture here there looks nothing wrong with the detail that has been provided, we got to think of our structures actually, our designs in 3D. So for example, this here, in this project, although this looks great. We also had a change of direction with this jetty, which made this connection very hard to work with, required some special brackets. Also, as the piles were driven, this meant that we had to actually wait for all the piles to be driven, surveyed, before it could come in to be modelled, to design each of these bolted brackets, to provide that kind of millimetre accuracy that this kind of connection would provide. So we want to take care, kind of additional care with our designs to think about into the constructability, and that's what I'll move on to with our next slide. Is we want to think about our constructability of our project. So a lot of our drafting guide templated connections, we've factored in a lot of this over many years of working with contractors, working with our clients and stuff like that. So you'll find that a lot of these connections have a lot of flexibility with them for when things go wrong on sites. So we want to be, when you're thinking about your designs, you want to be thinking, what happens if tree root is right where I need my pile, and that needs to move? Does my connection design allow for this change without having to, resupply and different things like that? So I've got, and then kind of a bit of key takeaways. We want to use connections that suit FRP. This is why we've created the drafting guide. It helps you guys to better use connections that suit FRP products. We want to be thinking about constructability in our designs. Think about how things change when on site. You want to be clearly communicating your design in the drawing. So that's where we talk about, add details, use the drafting guide to pull your details from, and go the one little step rather than just adding text for a connection. And then just remember that we've got a lot of the work there for you to guide and help, and we're also here to help and guide with drafting and coming up with connections. So I'll hand this back over.
Just ask you a question there, Jace. You'd sort of, if you just jump back to that pier example, one of the bits you mentioned on there was the custom bracketry. I'd suggest from things I've seen, that's a lot of the connections that are specified by others and work. They do structurally work, constructability, they work. There's challenges sometimes, but they work. But a lot of the bracketry and connections in it are quite costly because they are so custom and so complex. Can you just run us through maybe how we try to standardize and simplify as many of these connections, because stainless steel in a boardwalk structure can make up such a big percentage of the cost if it's not well designed? Do you maybe just want to run us through the consideration for simplicity of connections, as well as sort of from a procurement sense, how you factor that into your work?
So factoring it into what I would probably would have done is, for example, this bracket went from one barrel on one side of the pile to the other barrel, so it was very dictative of its connection. if those piles were out of alignment in any way, like that bolt hole had to move. So that's where like its speciality came in. I would generally try to avoid things like that. Try to avoid a bracket that goes from one headstock to the other headstock on either side of the piles. That way it makes it a bit more simple to work with, and kind of avoids that kind of speciality in like delaying the whole progress of the build, to kind of, because wherever possible we want to kind of avoid having to do as-built surveys, and that during construction we want to kind of allow for a bit of flexibility within that. Other thing is where possible, you use the bolt, the bracket only on one side. That makes it easier when piles are kind of displaced from each other a little bit, or even at change of directions. Just on one side, bolt and bracket from one bearer to one joist would standardize that whole connection, and take away from it being a specialized connection.
Yeah, and I think it's important to note that all of the brackets that are designed in our drafting guide, we buy by the thousand, if not tens of thousands. So the cost base for those are a far more manageable point, and so is access for as things move. So maybe over to Georgia now, if you wanted to do the prelude, Georgia, we can give people any time they want to load any questions before we pile into some. Can we see if your mic's working?
Thank you, Georgia.
Yes, I might just double check that my mic is working. Apologies for the beginning, everyone. But I will just share my screen now.
Looks like we've lost you again now, Georgia.
Unfortunately.
I can, if you want to get
That's all
your...
right. Yep, Georgia, if you just want to keep up that drafting guide information, and I'll talk people through it. So Wagners CFT product guide is a comprehensive resource designed to support engineers. Sorry, we've gone to the product guide. That's right. And project teams throughout the specification process. It brings together our full range of FRP products, including structural profiles, decking, piles, and accessories in one easy-to-use document. In addition to product information, the guide contains key technical data such as dimensions, section properties, and material specs, making it easier to select the right solution for each application. Whether you're working on a civil, marine, or utility infrastructure project, the product guide is a valuable tool that helps improve efficiency and confidence during design and procurement. Use the QR code on the screen to read or download the product guide, and we will also include the links to that product guide in today's follow-up email. Mining and resource operations place enormous demands on infrastructure, particularly in corrosive and high moisture environments where traditional materials can deteriorate quickly. This blog explores how fibre-reinforced polymer provides a durable alternative by resisting corrosion, chemicals and moisture, helping reduce maintenance requirements, extend asset life and lower whole-of-life costs. It also highlights how FRP's lightweight, high-strength properties can improve installation safety and support reliable long-term performance across a wide range of mining infrastructure applications. So if you'd like to read that blog, use the QR code on the screen shortly. Now, there it is. And we'll also include the link in today's follow-up email. So we're going to dive into the Q&A session. I'm going to hand back to Ryan. It looks like we've got a couple of questions there. If anybody does have any questions for Jason or even Ryan, throw them into that chat now, or feel free to text them to George's mobile, which is in the chat as well. Over to you.
Thank you, Kelly. And yeah, just a note, if you do want a copy of the drafting guide, you can just request that in the Contact Us form, and we'll work out the most efficient way to get that across to you, and then organise follow-up sessions for Jason and the team to be able to walk you through that as you'd like. Jason, one of the bits is available in the drafting guide. I mentioned availability of bracketry and hardware. We've also factored in commonly available material sizes into things like our bushes and other material types. You just want to maybe take us through a little bit how those hard lessons have been learnt, and maybe how our connection details. What's the thought process that goes through selecting a connection detail that will become standard?
Yeah. Okay. I'll try and. I might go to probably one of our connections that probably has morphed over time. So probably a most common connection that has taken a lot, gone through a lot of morphing over the years is probably our handrail post to joist kind of connection. I remember when I started working here, we had bolted connections from the joist to the tie brace or bearer with inserts, and we'd use inserts in the joists for both the handrail post and for the tie brace connection. It was a fully kind of bolted connection. Over time and talking with contractors and understanding their kind of constructability concerns with this connection, we've then gone into the development and modified. First, we kind of took away the inserts, started using bushes in the joists. We still use inserts in our posts and the tie brace, because those we generally manufacture here. So anything that kind of makes jobs on work on site easier, where we do a little bit of prefabrication with our connections. So we would post generally drilled here, tie braces, and then the other thing is we were able to get rid of the bolted connection from our joist to tie brace and bearer by further doing testing and development. First, we had stiffeners on this bracket. Now we generally don't have stiffeners on the bracket unless we have high handrail loads greater than your standard 0.75 kind of top rail hand loading. Then we'll generally have beefier connections down here, but for standard Australian standard loads, this is all catered for in that development of design.
So am I right, Jason, in summarising then, we've got constructability, which is probably where we hear the most amount of noise. We've got cost, both in construction, which we covered in a previous webinar as well, was around the cost elements of construction and how choosing the right connections at your detailing stage can have a considerable impact on your construction cost. We've got availability of raw materials, so availability of bushes and tubes and rivets. We don't want some custom rivet throat length that makes it impossible for us to procure. And then we've also got that pre-assembly component. A lot of these connection details have been made specifically so then elements of it can be pre-assembled, again, to reduce your on-site construction time. So it's sort of a multifaceted piece, and that's why there has been so many iterations of them, because we make a change and then we get noise from one group, and then we make another change, and then we've got a contractor saying that's too hard to build. So what people are seeing here is what we feel is the best of both worlds that we've taken 20 years to develop. Question from Marcus Tomkin, and this is a poisonous one, Jason. I'm an architect, structural draftsperson using Revit. Would I use the guide and resources to provide up to the point of structural engineering drawings only, then Wagners produce the workshop drawings? Jason, maybe you want to start on this question, and then I can maybe share an example of why we look at it this way.
Yeah, so we, in kind of more the architectural side, we want to kind of, allow the design to be structured in a way that where our kind of standard connections generally work. So we want to keep in that mindset. We don't, as a architect kind of side, we don't, understand, we don't want to include all the full, detailed connections, but we want to be able to understand how they need to work when we're designing our project architecturally. So yeah, although in an architectural world, we may not pull from this, but it is a great learning tool as to understanding how our structures are kind of put together. That way it makes an easier choice, a bit easier idea on how to architecturally design the structures.
Yeah, so I guess my point there, Marcus, would be that this drafting guide is to enable you to take it to the full detail. We're happy to help do takeoffs, and Jason's built a lot of programming in the back end of our Revit models to enable us to do takeoffs more simply. But where we've seen a lot of the difficulty previously is where other engineering firms or other drafting firms have taken it to an engineering detail only and not actually detailed out the workshop drawings or each of the connections. So there's sort of fundamental clashes or misalignments, particularly when you look at it in the 3D space or constructability space. That means we actually have to tear apart a lot of the engineering that's been done to draw out or to model out the clashes. So the whole intent of publishing this drafting guide was to give other design groups the ability to be able to do full design all the way through the process to IFC drawings and workshop drawings that we can pull a schedule from, pull a bill of materials from, fabricate and dispatch. So that's why we have Jason and his whole team of drafters and structural design engineers, is to assist companies like yourself to be able to work through that. And they'd be most pleased to sit with you and go through training sessions or whatever you might need to enable you to take it that step further. We'll pile into Scott Burnett's question here, and I haven't pre-read this one, so I'll run into it. I'm a new draftsperson in an engineering company. For the purpose of IFC drawings, not shop drawings, we ordinarily create a new project utilizing the company Revit template, standard workflows and protocols, and then copy elements from the Wagners project and create new sections and copy text across into those sections to recreate the details needed. Would you ever recommend to draft within the Wagners drafting guide project in any circumstances? What would you say is the best workflow for working with the drafting guide, factoring in potential rework to recreate, illustrate connections, etc.? Is a feasible workflow to perhaps link the Wagners project to a main project for the purpose of streamlining the usage of details? Jace, as the cover said, I'm not someone that lives in the CAD world every day, although I do have an engineering ticket, so this one's going squarely to you. But thank you for the thoughtful question, Scott. And if Jace doesn't answer it in enough detail for you now, we do encounter this a fair bit, and we have helped other companies work through their workflows, particularly when it includes civil and electrical and all the other parts of a project that it might make up. But hopefully that's given you a minute to think about it, Jace, and over to you.
Yeah, probably thinking in the Revit world where a lot of this work can workflow can be done. So with Revit, yes, you can have a project file off to the side that you use details from. So yeah, you can perfectly use the Revit drafting guide as a kind of external reference device within your workflow, as somewhere to kind of pull the section details from into your project. I'd probably say, use your project template and that to build your model and everything from, and build in that workspace, and then use the drafting guide as that kind of external reference that you kind of link in, and then you can view, use the views or like the drafting views to kind of build in those connection details. On the AutoCAD side, these are kind of blocks. So you would use, again, your template, and then you just insert them as blocks into your AutoCAD drawing file. Yeah.
Okay, and yeah, Jace, we might connect with Scott sort of one-on-one after the session, just to work through that a bit more detail. That would be a good piece. Righto. So let's just pile into some of these other ones we had. So more generically, Jason, why do FRP connections require a different drafting approach to steel or timber?
Yeah, so I suppose if I give one word, is knowledge. FRP isn't a very well known product. So a lot of times, in every sense of the world, like even from engineers to contractors, they want to be careful with how they deal with things. So whereas steel, everyone knows what steel looks like, what the connections kind of look like. There's a lot more kind of knowledge out there for what they look like. So a lot of times you can get away with being a bit more, a little bit more less detail with the connections. But we find that giving everyone a big depth into the connection detail allows them to really understand how it gets put together a lot easier, and gives them that full that knowledge, that gives them that certainty to be able to construct and build.
Yeah, I'd say, Jace, just to add to that, if you're building with timber and you are a member short, or you need something a bit longer, it's available from the local hardware store, more likely than not. And with steel, a lot of your connection details can be made on the fly with welding, whereas with FRP, a lot more of your thinking has to be done in advance. Is probably a high-level summary that I would add to that. And our ability to really get efficiency from cut to length, and reduce your on-site time is probably the other piece. Normally when you order timber, you'll get 10 packs or 10 sticks at 11 meters long, and that's what you're getting regardless of whether you ask for it or not. Whereas our world, we can send very specific things. Another question from Scott, and this is more of a commercial one, so I might even tackle it, Jace, but it's good to see Magrin, as always, looking at the commercial side and trying to look after their clients. If a client or their engineering or their engaged engineers supplies Wagners with a working Revit model using Wagners items, does this provide a cost saving on Wagners' side, which is then passed on to our client, as would help you do your own verification bombs, etc.? Absolutely, Scott. Time is money, as for everybody. If we have a model turn up here that we can use, do a material takeoff, or someone sends us a material takeoff, our project management time, the saving is not just in the drafting reduction or the engineering reduction, our project management time for that job can also be significantly reduced because someone doesn't have to sit there and work through design iterations or verification checks or bill of material generations. We can click a button and generate that data. So I guess the savings are more than just the design component. It's also in that sort of project management and project engineering time as well. So absolutely, there's a cost saving there. Jace, maybe just at a high level, and this might be one of our last questions. I can see Scott's got another one coming, so I'll make sure I answer that after this as well. How much detail is enough when documenting an FRP connection? So, if we really talk around our material types and our connection details, we work on the base assumption that the people constructing our boardwalks are not high-level, expertly qualified carpenters. Jace, that's a fair comment. We try to work on an experienced labourer. Is probably the level we'd like to think that people can build from. Is that the yardstick that we use for the level of detail that's needed?
Yeah, that probably a good estimate where we want to be able to put enough detail in there that explains you want to explain your design properly, whether you've catered for a crush block versus a bush. Those are the things that you want to be able to put into your drawings that you convey the difference between those, because they do have different connection capacities that you would have considered. So that's probably one level that you want to have those kind of things clearly in there for the contractor to estimate his construction.
Yeah, okay. And just to answer Scott's last piece, even if it does not all repeating connections are shown in the model, generally showing one section for each instead thereof actually detailing every single one. Yes, typically we'll just do a schedule at the front of the drawing, so I'd say 47 times A4 connections would be enough detail for us to be able to do our takeoffs, to do our bill of materials, and to then be able to reduce our project management time. So yes, you do not have to actually detail every single one. We do the same process ourselves, Jace. In some jobs, we'll detail every single connection if it's a very complex one. If not, we'll just detail a few of them, and then in a schedule at the front of the drawings, we'll just count out the number of those connection types. There's no need to model things for days if it's just a repeat of the prior one. And then our guys typically will just do a manual takeoff with a highlighter and verify that you've called out there's 47 A4 connections. We'll just validate, yep, we're comfortable there is 47, and move from there. And I'd just add before we close that at a design side of things, there can be real cost efficiencies gained for your clients that you're working for in making contractors that are going to tender the work easily able to tender the work. If they have to go through the highlighter and do takeoffs themselves, they're probably going to round it up. I counted about 47 A4 connections. Let's just make it 50 or 100 so we can make sure we're safe, cost that in and move on. If you can give in the drawings that you present that will go to tender, if you can provide really good quantities, that will help your clients get cheaper construction bids from contractors because it's easier for them to cost it and they're taking less risk themselves in how they've built it up. So, that just sort of links into the two prior webinars that we have done, which is all around constructability and cost of connection. So it sort of pairs it together as a three-part series. This is the one really in the details, but the reason the details matter is constructability and cost. So on that note, Kelly, we'll pass back to you to wrap up. Thank you very much, Jason.
Thank you.
Great. Hopefully everybody can see my screen there. That concludes our presentation today. As Ryan said, keep an eye out for that follow-up email that we will send to you before close of business today. We will include the links to part 1 and part 2 of this series, just in case you missed them, along with any other additional resources and information that we've discussed during today's session. Finally, a big thank you to Jason and Ryan for your involvement. If you'd like to share your thoughts on today's webinar, please feel free to complete the feedback form by using the QR code on the screen there, or I've just popped the link into the chat now. Or perhaps you'd like to be a guest speaker. If that's the case, send me a message on LinkedIn, fill out the feedback form. There's a bit of a section on there about being a guest speaker. However you want to contact me, we would love to hear from you. Coming up in August, dearie me, we're really struggling today. Product guide, let's find the August. Here we go. Coming up in August, we're going to discover why New Zealand Electrical Network Vector chose fibre-reinforced polymer utility poles and crossarms for the upgrade of H-frames in Dome Valley, and explore the design of the longest span of an FRP utility pole in Kowal Island with guest speakers, Vector Senior Asset Engineer Keith Gu and Wagners CFT Global Utilities Lead. Great story, those two. You should be there if you can. There's the QR code if you'd like to join us for your free online seat or register to receive a recorded copy of that webinar. The link for that is also in the chat if you can't use that QR code, just popping that in there now. So that concludes our webinar for today. Thanks very much for coming. We're actually going to go out on the video that we came in on, and fingers crossed we'll have some sound this time. So enjoy, and we look forward to seeing you next time.